Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, today we will learn about phenol. Phenol is OH attached directly to a benzene ring. So if a question is asking for a functional group, for the OH that attach directly to benzene ring, it would be a phenol. So for OH that attach to a straight chain carbon, it is an alcohol. So both of them are under hydroxyl group, but we cannot write hydroxyl group as the functional group. So we have to specifically tell it is a phenol or an alcohol. Next, we will go into test of phenol. So phenol reacts with FeCl3, a purple solution is formed. So the test for phenol and alcohol will not be the same. So alcohol reacts with sodium, will get hydrogen gas, and the observation will be effervescence, and hydrogen gas release will give pop sound with lighted wooden splinter. So we could also make use of PCl5 and SOCl2 to find alcohol. So alcohol reacts with them, HCl is formed. So HCl will give us steamy white fume. There will be a question asking us to describe a test to differentiate phenol and alcohol. Compound A, it's an alcohol. So the reagent to use to differentiate both of them, we can actually make use of FeCl3, where FeCl3 reacts with phenol, a purple solution is formed. And there will be no reaction with alcohol. So besides this, we could also make use of PCl5 or SOCl2. So where PCl5 and SOCl2 will react with alcohol, and the observation will be steamy white fume. And there will be no reaction for phenol. Besides these two reagents, we could actually make use of an oxidizing agent, because this alcohol is actually a primary alcohol. So where we can make use of K2Cr2O7, potassium dichromate. So where potassium dichromate will oxidize compound A, which is a primary alcohol, and the observation will be orange solution of potassium dichromate turns to green. And there will be no reaction for phenol. Phenol is actually a weak acid, so it dissociates partially in water to give us phenoxide ion and H+. So this is actually a phenoxide ion. So let's go for the reaction for phenol with sodium. So phenol react with sodium, we will get salt plus hydrogen gas. And next, phenol will react with NaOH to give us salt plus H2O. So the observation for this reaction is that phenol will dissolve. But there will be no reaction for phenol with sodium carbonate. So students always were confused between three of them, where we have alcohol, phenol, and carboxylic acid. So alcohol is neutral, where phenol is slightly acidic, and carboxylic acid is acidic. So let's put a tick if three of them able to react with sodium hydroxide, and sodium carbonate. So alcohol will react with sodium, but not NaOH and sodium carbonate. So phenol will react with sodium, NaOH, but not sodium carbonate. So where carboxylic acid will react with three of them. So this question may ask us to make use of three of these reagents to find them out. This question to go, we could make use of sodium carbonate to find carboxylic acid, where we have sodium carboxylic acid react with sodium carbonate, it will produce carbon dioxide gas. So where carbon dioxide gas will give us efflorescence, and gas turns lime water cloudy. So this could eliminate G, so we left E and F. So next we could make use of NaOH. So NaOH can find phenol. So where there will be no reaction for alcohol with NaOH. So for E to go, so we have E reacting with NaOH. So the observation will be phenol, which is E, dissolve in NaOH. So next to go will be reaction for phenol. So phenol will have benzene ring in it. So the benzene ring in phenol will undergo electrophilic substitution. So we will go for the very first reaction, which is nitration. So for nitration to go, we would need to have dilute nitric acid. Condition will be room temperature. So there will be no concentrated sulfate needed, and heating as well. So because OH is electron donating group, where it will activate the ring. So the substitution will occur at the second carbon and the fourth carbon. We could actually find this in data booklet, where we have OH in the table. So where we can actually find that OH, the substitution, if OH is the branching, the substitution will occur at the second and the fourth carbon. So therefore, the reaction to go for nitration, the product will be 2-nitrophenol and 4-nitrophenol. So if the condition is slightly more critical, to have concentrated nitric acid with no room temperature as condition, the substitution will be tri-substitution. So there will be substitution at the second carbon, fourth carbon, and the sixth carbon. So the product will be 2, 4, 6 tri-nitrophenol. So the last reaction to go, it's hydrogenation. So we make phenol to react with Br2 aqueous with room temperature as condition. So since OH is the electron donating group and the ring is activated, so therefore this reaction doesn't require AlCl3 as the catalyst. So for this reaction to go, there will be substitution at the second, fourth, and sixth carbon, so where there is tri-substitution. So the product will be 2, 4, 6 tri-bromo phenol. So this reaction gives us 2 observations. There will be questions asking for observation as well, where it will be 2 marks. So where the observation for this reaction will be Br2 turns to be HBr. So brown solution of Br2 is decolorized. Next, we will get white precipitate in this reaction as well, where it is actually from 2,4,6 tri-bromophenol. So this would give us 2 marks. So that's all for the reactions of phenol. See you in the next video.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.